Hi everyone, welcome back to the workshop, and it's repair time again. And this time I've got an HP 344001A 6.5 digit multimeter. Now this one is faulty, I know that, and I have heard little tales about what's wrong inside the unit, so I'm not going to power it up. I'm just going to strip it down straight away and let's take a look inside. Now actually, before I go inside, there is actually a strip of masking tape on the front there on the top side. It's got some error codes on it: 612, 613, 615, 617 and 619. But let's open it up and let's take a look inside. Well, and there we go, and as always these units tend to be very clean inside, and that's down to the lack of fan. There is no fan assistance on these units, so it is actually pretty clean inside and on the back. Now looking on the top side there, I don't see much of a problem anywhere, but let's take a look at the other side. And yep, that's not a shadow, that's a severely burnt PCB. Now let's turn it over again. And it's actually under this protective plate at the end here, so I'll remove it now. Let's take a look at that. And wow, let's see if we can zoom in a little bit closer. Just look at the state of the corner of that circuit board there. There's a whole bunch of resistors there that have obviously been heating up to the point where it's actually burnt the actual PCB. So let's take a look at the schematic and the component layout, and let's see if we can work out what those resistors are for. So here's the actual component layout for the circuit board, and I've orientated it the same way, and there are those resistors there. And here's the actual block diagram for the unit, and you can see up here on the top left you've got the front panel selection, you've got the front terminals, the rear terminals, and the mechanical front rear switch, and the resultant signals from there then go into this function switching part of the circuit here, and you've got a mixture of mechanical relays and also solid state function switching. And you can see there you've got a high voltage divider as well, and this is actually where the problem lies. That's why you've got those relays pretty close to those 13k resistors. So you've got the front panel and the rear panel input sockets there, input bananas, to then redirect the actual signals accordingly on the rest of the circuit. And over the right hand side you end up with an XREF high, an XREF amps, an XREF low sense and an XREF high sense. So there are your 1, 2, 3, 4 signals that will go on to the rest of the circuit. Now in this diagram here you can see XREF high coming in, and it comes into K101, and you've got some switching there, enable some other functions, but the resultant signal will then go up through K103 if we're talking about DC voltage low range, and that goes through those 13k resistors into U101. The other signals switched by the relays, you've got DC voltage high, you've got the high sense, AC out, and the low sense, and also a ground coming into the same U101. Now if I look at this little table, it actually does describe somewhat the function switching, and it actually mentions the input high terminal is redirected to the various measuring functions through K101, 102, 103 and 104. And this nice little table gives you a description of what the status of the relays are set to in order to achieve the different functions. The VDC low range, high range, 2-wire ohms, 4-wire ohms, etc. right through current. And at the right hand side you've got a sensat column which just describes where those actual signals end up going to. So going back to this schematic, like I said, there are those 13k resistors. You've got a couple of capacitors as well. They're actually 5% 1 watt resistors each. And you've got a couple of inductors at the right hand side there. So as I showed in the schematic, those 13k resistors, the signal going through them actually terminates at U101. And here is U101 down here. Now it's actually quite far away from the resistors. Now if there's been a lot of current flowing through those resistors and the tracks in between them, if there's any problem at this end, you would think that something might have melted, the track might have melted between it. But I can't see anything. But on both sides of the board, there doesn't appear to be any evidence of anything heating up around here. So it looks quite local to the actual resistors. So I'm actually going to probe those two capacitors and let's see if maybe one of them is dead short or something like that. So let's take a look at the schematic again. There's C101 and there's C100. Now you can imagine if C101 was dead short, then a lot of current would flow through that relay, through the resistors and down to ground. Especially if the two inductors are still intact and the line going away off to U101. So let's take a look at C101. I suspect that might be the problem because all of those resistors along here are burnt out. So I don't think it'll be C100. So we'll take a look at C101, the one that I suspected anyway. 25.4k, that one looks okay. Okay, let's take a look at C100. We'll go across it. Wow, 1.5 ohms. So maybe it's C100 that caused the problem. And back to the schematic again. There is C100. Now it did look like R110 and R111 were actually, melted or heated up as well. But that could just be the proximity effect of those other resistors to it. It's either that or this diagram's got them back to front, which is often a problem with these HP schematics. But anyway, I think the next thing to do is actually to strip down the unit. Let's get the circuit board out and take a closer look. Well, there we go. There's a better look at those resistors there. And this relay actually is the one that actually feeds those resistors. And I think there may be a little bit of a bulge on the top side of that relay there. So yeah, that would have pulled a bit of current through that relay contacts as well. So yeah, we'll need to replace that. So nothing else looks to be burnt around this area here. There's your front rear switch. And yeah, bridge rectifier, a few resistors. Now the two inductors that I showed in the schematic that are fed after those resistors, there they are over here and they're perfectly intact. No problem with them at all. There's a track there, you can see it comes away along here underneath those two components there and away off ultimately to the actual resistors over here. So there is C100 there. Yep, it's got a crack in it. You can tell it's been melted as well. That's a capacitor that's gone dead short. The 470 picofarad is it? I think. Yeah, 470 picofarad. I think that just loaded up all the current through those resistors there and burnt them out. Wow, one capacitor and look at the damage it does. So how on earth do 8 13k resistors catch fire? Well, if we try and assume that if each resistor had to dissipate 4 watts, then the likelihood is it would get really, really hot and perhaps catch fire. So let's plug in the formula. P equals I squared R, rearrange that, I equals the square root of P over R, that's 4 divided by the 13k, that's 0.0175 amps. So therefore, 17.5 milliamps flowing through those resistors. You plug that in and work out the incoming voltage to achieve that current. Well, V equals IR, 0.0175 amps times the 13k, that's 227.5 volts across each resistor. Times that by 8, 1820 volts. Now the person that gave me this meter to fix also mentioned that the meter was possibly being used to test 500 volt 1000 watt power supplies, and that possibly the front rear switch had been activated whilst the meter was connected. So maybe the meter was being used as an ammeter at the time, and maybe that bounced high voltages across the input circuitry. Well, how am I going to fix this? Well, obviously I'm going to remove those resistors and chuck them away and put some new ones on. However, the actual PCB is being burnt up and it's all basically turned to carbon, and carbon's conductive, so I can't really put new resistors in its place. I'd probably have to scrape away the circuit board and try and get rid of all that carbon. However, if you look at the other side of the board, it's burnt right through. So basically this whole corner of this circuit board is absolutely useless. So what I'm actually going to do is, I think I'm going to cut that burnt brown section right out. And then I think what I might do is design a circuit board in KiCad. It'll exactly fit what I've cut out, and I'll have the actual pads for the resistors on them, and then I can somehow or other glue it into place or bond it into place there. So to go about this, I've mocked up a small PCB before I ordered it, printed it out in paper just to make sure that it fits in where I'm looking to cut the PCB. And yes, cutting it right up the top there, decided, in order to fit these large resistors in place, and down an angle like that and back down there. And the reason I've left this area here empty is actually because it's required by the front panel. And you can see on the front panel where the PCB sits in here, and actually if you look closely, there's some smoke marks against the back end of that display PCB. Yeah, looks like it did catch fire. Now the other option I've got is not to actually cut this PCB out, but to actually elevate the new one above the old one once I've stripped the parts off. I can put a standoff between these two holes here and just mount it there. Now the slight problem I've got with that is that actually the PCB sits between these two plastic parts here, and it just sits something like that, and to elevate it I'll have to raise it up by at least 10 millimeters to clear those two plastic brackets there. So we're talking about right up there. Okay, so let's get going. The next thing I'm going to do is I'm actually going to remove all the components and remove that relay as well. Try and clean up the PCB, both sides, get rid of as much that carbon as I can in preparation for either cutting out the PCB or laying up the new one over the top. Well, there we go. I've scraped it down a little bit, and look at that charred PCB. It's basically charred right through the FR4, and yeah, you can see the weave of the actual FR4 there, hopefully, and it's just right through. And if I turn it over, you can see that side as well. It's just as bad. It's just right through. So okay, so here's a relay removed from the board. And I just thought I'd try and test it out and have a look at it due to that bulge in the top side. So I've actually gone ahead and cleaved off the top. It's actually quite rather easy to do. All you need to do is take a scalpel and then just go in at one corner, and the top more or less just comes away by itself. It's really thin plastic. Now, looking at it, doesn't look like there's much wrong with it at all. Nothing looks burnt out or charred or anything like that, given a lot of current has gone through one pair of the contacts there. So I thought I'd hook it up and let's try it out. Now, it is a 10-pin relay, and you've got a changeover contacts at this side, 3 pins there, and you've got another changeover contacts at this side here. That leaves 4 pins for the coil, and that's because it's a set reset relay. You've got 1 coil for set and 1 coil for reset. So let me hook it up to my breadboard and my power supply. It's a 5-volt relay. We'll put power into it and let's see if we can see the contacts actually moving. Okay, here we go. I've got it hooked up. So you can actually see the contacts. That's one lot there and the other one at the other side here. And if I just go onto the set side, you can see it both of them go across, and the other side. And if I just go back and forward, in fact, it's not staying in the one position. It's actually wanting to actually spring back to the reset position. And I think this contact over here, if you can see that, looks like it's travelling further onto the actual contacts either side. But this one here doesn't seem to be getting all the way across. It seems to be stuck in the middle there sometimes. It's working more reliably now. In fact, it's travelling further now than it was. But given a lot of current's gone through this relay, I really don't trust it. So I have actually got a new one on order. Let's hope it is exactly the same and works as a good replacement. Well, I've got my circuit boards, as you can see, and that's thanks to PCBWay, not only for sponsoring this video, but for actually supplying these boards free of charge. Thank you very much, PCBWay. And as you can see, they look absolutely spot on, right down to the solder mask resist area that I've put there to match the original board. And I've put one of them loosely in place there. Actually, I think I've decided I'm not going to actually cut out the board. I think it's a little bit too much trouble there. So I think I'm just going to go with this riser method where I lift the board, in this case put 9mm spacer in there. Well, there we go. I've fitted the resistors now and it's looking pretty good. The only thing I've got to check now is make sure that the board and the riser that I've got set there at the 9mm fits correctly on the actual display board. So let me just offer it up now. And there it is in place, and yep, it fits perfectly in there. No problems whatsoever. So the only thing I've got to do now is fit the actual relay and drop the connections down from that new board onto the main board, and a little bit of tidy up on the underside of the board as well. The next thing I'm going to do is take a look at this front rear switch here, because if we take a look at the schematic, you'll see that the front rear terminals go through that front rear switch here. So the high voltage heavy load would have gone straight through those contacts. So I need to make sure that switch is okay. So I won't need to actually remove the switch contact from the PCB. I can actually remove the mechanism here and pull the contact rod straight out of this housing here. And I'll do that via this little tab here, which actually holds it back in against the spring here. So what I'll have to do is pull off this little clip here. There we go, push it around to the side. And then I'll lift that tab and pull the mechanism out. Now I'll do that off camera and get my head right over it. And there it is on its way out. And straight out. There we go. And that's it out. And looking at it, this one here does look a little bit worn. The other ones are clean. And turning it over, you've got to be very careful you don't let these springs pop out. And this one here looks a little bit worn also. Not much I can do about that. I'm not going to try and rub them down, but certainly they're not burnt out. And what I'm looking at here now is down in there, through this red block here, is the actual contacts. So let me see if I can zoom in and actually focus on the contacts either side of that little switch block there. Alright, let's see if I can manually focus down the side there. Yep, you can see them down in there. That's one side down in there, and let me try the other side. And that's the other side down in there. That looks pretty good to me. Now I do actually want to clean the inside of that contact block, but it's made all the harder with this red block being in front of it. So I need something long and thin that can go right through and I can use to clean the inside. So I'm actually going to use one of these, and this is from an old COVID test kit. And it's just perfect for the job. A little bit of IPA in the end and I should be able to go right through and into the contact block. So let's try that now. And they're not like cotton buds where they're all hairy and the chance of leaving something behind. This is a bit better than that. So here we go. And yeah, perfect for the job. So I'll just try and go down one side and then down the other as best as I can. And also give the contacts a little bit of a clean as well. Perfect. Okay, I'll reassemble that. That's it. And the next thing, all I've got to do now is put in the little guide there that allows it to go from latching on and latching off. Now the little clip is got a little kink in it, and that's so that the spring can sit in there. So I've just got to pull it back a little bit and put the clip in place. And that's it, working perfectly. And you can actually see through the side of the switch because it is actually transparent, and you can see it actually working there. Well, that's about as far as I can go for this video. I'm still waiting on the replacement relay arriving, so there will be a part 2. So, thanks for watching, and remember, you can always comment down below, and don't forget to like and subscribe. It really does help the channel grow. There's plenty more repair videos on my channel, from the simple to the complex. Check them out, and thanks for watching.